Welcome to Brain Vision.
Well, we have the bullet's mass. Well, bullet's mass is mb, and bullet's mass is equal to 12.0 gram, and 12.0 gram is equal to 0.012 kilogram. Well, its initial velocity is 380 meter per second. So initial velocity of bullet, let's call initial velocity VB1. VB1 is equal to 380 meter per second. Well, the ballistic pendulum's mass, let's call it MP. Mass of pendulum is 6.00 kilogram, and its initial velocity VP1 is equal to 0. Well, we know that in collision of all kinds, since there is no external net force on the system, the total momentum before the collision equals the total momentum after the collision. So we can write total momentum before the collision is equal to total momentum after the collision. Well, if the collision is between two particles, say A and B, then this momentum equation can be written as PA1, so that's initial momentum of particle A plus initial momentum of particle B is equal to final momentum of particle 2, right, plus final momentum. This is final momentum of particle A plus final momentum of particle B. Okay, so it's a vector, and we know that momentum is given by, well, momentum P is given by mass times velocity. So momentum is equal to mass times velocity, and therefore we can write the collision equation in the following form. Well, MA times VA1, right, plus MB times VB1 is equal to MA times VA2 plus MB times VB2, right? Well, let's call this equation number 1. Well, this is equation number 1. Well, now let's do calculations. Well, for the collision, since the forces that the bullet and the pendulum exerting on each other is large enough to ignore the air drag, then there is no external force. So the momentum is conserved during the collision. And since the bullet remains embedded in the pendulum and they have the same velocity after the collision, and therefore we have VB2, right, is equal to VP2 is equal to V2. Now let's plug the values in equation number 1, right, in equation number 1. Then we have 0.012 into 380 plus 6.00 into 0, that is equal to 0.012 times V2 plus 6.00 times V2, right? And now solving for V2 is equal to 0.012 times 380 divided by 0.012 plus 6.00. So V2 is equal to 0.76 meter per second. 0.76 meter per second. Well, after the collision, gravity is the only force acting on the system, right? Well, now let's calculate the kinetic energy on the system right after the collision, right? So total kinetic energy, well, let me scroll down. Well, total kinetic energy is equal to half m total times V2 square, and that is equal to 1 divided by 2 into 6.00 plus 0.012 into 0.70 whole square, and that is equal to 1.73 joules. 1.73 joules. So total kinetic energy is equal to 1.73 joules, right? Well, from the conservation of energy, this kinetic energy is converted into gravitational potential energy after the collision, lefting the pendulum a height h above its original position. Therefore, gravitational potential energy is equal to total kinetic energy, and that is equal to 1.73 joule. And now we can find out height. Well, we have gravitational potential energy is equal to m times g times h, right? And let's plug in values. Well, 1.73 is equal to 6.00 plus 0.012 multiplied by 9.8 multiplied by h, right? And h is equal to 0.029 meter, and that is equal to 2.9 centimeter. All right. And finally, we calculate the kinetic energy of the bullet before the collision. So kinetic energy of the bullet is given by 1 divided by 2 times mass of bullet times VB1 square. Let's plug in values. 1 divided by 2 times 0.012 into 380 square, and that is equal to 866.4 joule.